Welcome, dear friends. Today we are talking about the heat loss calculation of an uninsulated refrigeration pipes or partially insulated refrigeration pipes. To calculate heat loss from an uninsulated refrigeration pipes, you will need to determine the temperature difference between the pipe surface and the surrounding environment, the surface area of the pipe, and the heat coefficient that accounts for convection and radiation. The formula is Q is equal to H into A into delta T, where Q is the heat loss in watts, H is the overall heat transfer coefficient, A is the surface area, and delta T is the temperature difference. So, which factors you want to know to calculate the heat loss calculation? In this figure, you can see there are two things. One is the pipe surface temperature. This is measured directly or estimated based on the refrigeration temperature and the properties of the pipe material. And the ambient temperature marked by number 2. This is the temperature of the atmospheric air. Calculate the temperature difference, subtract the ambient temperature from the temperature of the pipe surface. Calculate the surface area. If the pipe is cylindrical, then the formula is pi d into L. The overall heat transfer coefficient H. This is the most complex part of the heat loss calculation as it depends on both convection and radiation. What is convection? Heat transfer between the pipe surface and the atmospheric air. This is affected by air velocity and the surface roughness. You can use correlation like Nusselt number to estimate the convecting heat transfer coefficient, and the radiation is heat transfer between the pipe surface and surrounding surfaces, wall, etc. This depends on the emissivity of the pipe surface and the temperature of the surrounding areas. The overall heat transfer coefficient H is often a combination of convection and radiation heat transfer coefficient, and the formula to calculate the heat loss is Q. Once you have H, A and delta T, you can calculate the heat loss using the formula Q is equal to H into A into delta T, and you will get the answer in watts. So now it's time for an example. We have a 3 inches diameter pipe, which is uninsulated steel pipe. Length is 20 meter. It is carrying a refrigerant at 0 degree centigrade in an ambient temperature of 23 degree centigrade. The pipe surface temperature is approximately 10 degree. The air velocity is low. So in this example, what we have? Temperature difference we have. Area of pipe we can calculate as we have length and diameter of the pipe. H, the coefficient of overall heat transfer is 10 watt per meter square Kelvin. So dear friend, let's place these all value in the formula where delta T is 13, area of pipe is pi dl is equal to 4.785 square meter, H is 10 watt per square meter Kelvin, and when we calculate the Q is heat loss is 622.09 watts. So this equation or example has the total heat loss is 622.09 watt. The accuracy of the heat loss calculations depend heavily on the accuracy of the estimated heat transfer coefficient, which you can get from the HVAC's handbooks. Thank you friends for watching this video. Please like, share and subscribe for more informative videos. We love to see you again. Thank you.